So hey guys, let's solve the problem cut ribbon of code forces. And like it is pretty simple problem because like it's a level problem of diff 2 round. So let's read the problem first. Polycarpus has a ribbon and its length is n. So basically there is a ribbon which is of length n, and he wants to cut the ribbon in a way that fulfill the following two conditions. So basically you have to cut that ribbon in such a way that after cutting the ribbon, like you'll be having some ribbon piece, and that should have length only a, b, or c. Like you can have something like, suppose if you have the value of n as 3, and suppose if the value of a is 3, b is 1, and c is 2. So basically you will be you'll be having, uh, let's say, by considering this, you can have only one piece. By considering this, you can have three pieces, each of length 1 unit. And by considering these two, you can have like two pieces, and so on. And the answer should be 3 in this case. So this is your problem. So I know that like this problem is can be like solved by the use of dynamic programming, and I'm going to show you like how to correlate this problem with the standard problem of dynamic programming. And I'm referring here the standard problem as coin change problem. So basically I am going to use that like minimum number of coins that are required to generate the amount m, that problem and the approach of that problem. And I will be correlate that problem with this problem to solve this problem. So the only difference, like there are only two differences here. The pieces should be of length a, b, or c. So you can take these pieces as number of coins. So suppose you have only 3 coins which is of amount a, b, or c, and you have your total amount as n, and you have to find out the maximum number of coins that would be used to like lead us to that amount n. And yeah, and the only difference is like in that problem minimum number of coins would be required, and in this problem maximum number of coins would be required. Nothing else like would be different from both these problems. So I hope you know like how to solve minimum number of coins change problem. And if you don't, like I'll be sharing the recursive solution part in this also. So let's say you have some function solve, suppose, and you have suppose some I, and you have n, which is given in the question. And let's find out first the recursive part. Okay, so suppose if the target is 0 itself, so how would you generate any like any amount which is already 0 by the number of coins? No, it's not possible. So if n is 0, then you can return simply 0. As simple as that. Now you have like in this problem, you have 3 possible coins that you can use to generate that amount, right? So let's say you are iterating over these coins. Let's say you are iterating, let's say you are run a for loop here, and that loop runs from, suppose this is j, and that loop runs from I 0 to I, let's say, and I is the position of that coin. Suppose you have an array for these coins, and I is the position of this coin. And ultimately you have to find out the value of 2 comma n in this case, because you have to look forward like all these 3 coins to solve the problem. Like you can't say I'm only considering this coin and I'm going to solve this problem. No, it can't possible. Yeah, you can also move the other way around, and you can also like find out 0 comma n by just iterating in a different way. So let's say 0 to I, and you are just maintaining a variable, let's say temp, you are solving that problem like with this, because you know that this solve function will give you the exact answer. So you want to find out like, if I am taking this, then what should be the answer? Okay, so suppose if you are taking like j0, that means like this array, let's say arr. So let's say this is yeah, so this is 2. So basically you'll be having I comma, now this n would be would be reduced to some value, because you know that like you are using some coin. Yeah, there is one condition: when your coin's value is less than that total amount, then then you'd be required to call this function. Otherwise, like there is like there is no need to just use that coin which has the value more than or greater than this target value. Like, then how would you use that coin, right? So here is also a condition: when your coins value less than or equals to that value of n, then you will be doing this. So let's say here, if your coin of j is less than equals to n, then you need to call this function solve. And yeah, so let's say here you need to write n minus coin of j. I know that like I'm using my mouse to write this, so that's why it is like I'm writing kind of a in a vague manner, so sorry about that. And something you need to find this: suppose you have find out the value of like temp for all these coins, then you just simply need to print the maximum of this temp, and you need to require some variable. Like, I can show you by writing the code of it, because I'm not sure you will be understanding this part. So yeah, I've already I've already initialized my like dp array, 2D array, 3 into 4001, y3 or y 4001, 3 because we have only 3 coins, and 4001 because we have the constraint of 4000. So that's why I've already taken 4001. And arr3 is because of coins. So I've already taken the input, and I've already initialized my dp with -1. I will be like I will be explaining you like why am I taking this. And I'm just I've already told you about this, like why we need to required to call this 2 comma n. You can also do it by 0 comma n by just reversing that like for loop. So let's write our recursive cases. So if m equals to 0, right, or let's say less than equals to 0, then we just need to return 0. After that, we just need to run a for loop which start with 0 and go till n and I plus plus. Okay, now let's say we have some value of temp, and temp will solve this problem, okay, by just taking. So what should be the value of n here? Just tell me what should be the value of n here, and you know that it should be like m minus arr of I, right? What should be the value of m here, n here? So if you are taking I, right, if you are taking I, so you need to write n. Why n? Because you only need to know the answer of solve 2 comma m, right? So you are solving it for only, and you are iterating, so don't need to change this variable. This remains constant. right? You are only doing the recursion part over this part because you have already wrote the base case here. So let's say you have already find out the answer for this number of coin by considering this number of coin. So suppose if you find out, then you just need to write a simple if condition, because you have already find out the answer of this. Now you have already considered one coin for solving this problem. And one condition is also very important here. If the ARR of I is less than or equals to the value of M, then you need to do this. Otherwise you don't. And now you have already considered one coin, right? So if you have already considered one coin, then you also need to require to increment that value by 1, because it is giving you the value of like value for this amount, and you have already used the coin. So you need to do 1 plus temp. So one thing, we have to make some answer which should be int max, because int min, because we need to require to find the maximum value in it. So if your answer, right, if your answer is less than, okay, or no need to equals to less than 10 plus 1, then your answer should be temp plus 1. Yeah, okay. And you simply return this value answer. This is the simple recursion part, but here the constraint is very high. Not very high, but yeah, it won't be possible to solve this question using simply recursion. So you need to memorize using this 2D array. So it's very simple to use it. If your dp of n m is not equals to -1, just simply return it. dp of n and m. Otherwise, you just need to store your answer. dp of n m equals to answer. Let's check. I hope it will work. Yeah, it is giving 2. Let's check for other case. Yeah, it is giving 2. So let's submit this code. So cut ribbon. Let's check. Okay, it's accepted. Yeah, I know that this can be solved by like we can also do some optimization to just solve it in a better way. Like we can also use some mathematical approach for solving this question within some less amount of time and space. But I am here to show you like how to correlate this problem with the minimum number of coin problem. Because in minimum, if you are solving the minimum number of coin problem, you're only required to change some few lines in this code. Like this answer should be int max, okay, because in that problem you'd be required to just solve for minimum number of coins, and in this case you are required to solve maximum number of coins. And I think otherwise, like, yeah, all of the part you should keep it as it is.